All right, so hello everyone. Welcome to my presentation. This is my first time doing like original presentation, so hopefully it's gonna go well. So today I'm gonna be presenting on the typical porno starter pack, which is basically a meme. So if you just here for the meme, then here you go. This is the meme. I know it's bad. So I'm gonna go into talking about each of these things on the meme today. So first, who am I? I'm Doug. I'm a computing security student, third year from Vietnam. And basically what I do is reverse engineering and exploit development and pretty much a little bit of everything else. So I'm just gonna go right into what is this pwn thing about. So in the context of this presentation, it's binary exploitation. So it's if you've been doing CTF, it's basically the category that say like pwnables or like pwn, and that is basically what it's about. So what you're going to be doing in this is you're going to abuse bugs in programs to gain remote code execution, or sometimes you can do other things like just read files or like write to files or do anything on the machine that's hosting the vulnerable program. And there's some typical classes of bugs that you're going to encounter when you're doing this. They basically buffer overflow, like stack overflow or heap overflow, or use after free. So these are like the most common ones, but there's much more than that. But like I said, this is just a starter pack. So why do you do this? For me, part of the reason is that I think it just sounds cool. And the ability for you to gain like remote code execution on a whole machine by just abusing a program is pretty cool. And other than that, it's basically the basis for vulnerability research if you want to get more into this stuff later on. Or you can go with bug hunting about this. So usually from what I've seen is that bugs, like low-level bugs like this, are much more critical than I would say like cross-site scripting. But there's a lot of factors in this. But if you see like the exploit like Spectre or what's the other one, like Meltdown, it's basically like these low-level bugs. That's really critical, and it's affect a lot of common software that you use for example, like web browser, hypervisor, or like CPUs and stuff like that, or maybe even cars. Like recently, if you haven't heard of it, there's a competition where basically people just go there with their 0 days on different products like hypervisors, web browser, or even recently the Tesla 3 model, the car. And there's actually a team that get code execution inside the car system. I don't know about detail about this, but it's a pretty cool one. Or you can just, you just want to pick up a new thing, so you do it, and you want to learn more about computer architectures. So this is a little bit different from the red team or blue team competition that's been going around like all year at RIT. So in my opinion, red and blue team competition is more about like networking administration and like system administration. So this specifically is closer to like computer science and more like closer to computer architectures, where you're gonna be exploring like CPUs and seeing how the programs work inside the CPU and see how memories are used inside the program and stuff like that. So you can do it without a team. So how do you do it? How do you basically get code execution on computers that host these kind of vulnerable programs? Like how do you pwn? So basically in programs, there's a thing called the instruction pointers, or like the program counter. You may have heard of it. It's called EIP or like RIP or PC, just short for like instruction pointer and program counter. So this pointer is gonna tell the CPU which code that's gonna be executed. So the main idea is if you can control this pointer, then you can control the execution flow, and you basically can get code execution. Like you can execute whatever code you want. So, but when it comes down to like different softwares, the way that you're gonna exploit that piece of software is, it's gonna depend on the software itself. But I think in general, there's a high-level approach to pretty much everything. So the typical scenario that you're gonna see in this kind of exploitation is that you given a program that takes in some input, and it's gonna try to save your input to some memory segments. And what happens when you give it like a really long input is that it's gonna override that instruction pointers that I mentioned before. So when the CPU tries to access this instruction pointer again, that instruction pointer is already corrupted and it's already being overridden by your data. And the program is gonna be self-faulted. If you're not in mechanics, then you should be happy about that. So the high-level approach that I've just mentioned before, I think it basically consists of two phases. The first one is you need to find the bugs in order to actually exploit it. And the second phase is you write the actual exploit. So typically, for me, when I do CTF, the thing that you're given is binary programs like ELF, typically on Linux. So it's more like a gray box or like a black box to you. You have the binary, so you can do stuff with it. You can patch it. You know which library it's going to use and stuff like that. But in order to actually exploit it, you still know barely nothing about it. So there's two steps in order to basically gain remote code execution. So because you know nothing about it, you need to leak some information out of it. So basically, I'm going to call this like the read primitive. So when you gain information more about this black box or like this gray box thing, you can use that information to basically bypass like security mitigations that's enabled on the machine that's hosting that binary. Or you can know where to point your codes to, or you will need to acquire enough information in order to exploit the bug. And the second part of it is you actually go in and write the exploit and control the instruction pointer. So in this phase, in this step, you will need to write the data that you want to where you want. So basically, the instruction pointer is going to be somewhere in the memory. And you will need to somehow achieve that the right ability in order to corrupt that instruction pointer in order to gain control over it. So I just want to share like how did I get started in this. So you guys can kind of see like we all need to start somewhere. So back in like 4 years ago, I was just start picking up like binaries and I do reverse engineering. And basically I just use like IDERPO and I open that binary and I just hit strings. And if nothing interesting show up, I'm gonna give up on it. So that's how I did like 4 years ago. And then about a year after that, one of my friends, like actually, I tell one of my friends that I want to get started in this like hacking thing, just hacking in general. And he just showed me like this piece of code and just tell me like, can you make this program like crash? Like this program to me is kind of weird at that time because I was doing competitive programming. So if you know about this, like actually this is not the right one. You should just cross it out. Actually, it's just printf and like argv1. But at that time, it looks weird to me, but I don't know how to actually like make it crash. Like I can just like compile this program and like I give it some input and just print it out. It works like a normal program. So, but later on, I figured out that this is a format string error. Without like this format string like %s right here. So basically, this printf function was not used as intended. So basically, I can control like a piece of data that the program is going to use to carry out other operations. And then I guess when I got to RIT, I think it's like the 4th semester or someplace. I got my first CTF challenge, like the portable one. It was a Stack Overflow vulnerability that I'm gonna show you guys later in my presentation. It was like, there was a lot of people that solved the challenge, so it was like 15 points. But I struggled like a lot through it. I spent like more than 6 hours just figure out all this stuff, like what is knob, like what is the stack, why is it just crashing? Like I had no idea about this stuff at that time. So, but eventually I got the flag, but 5 seconds late, so it was sad. But all right, so I'm gonna jump into the starter pack right now. So the first thing I think is really essential is that you need to know how to program something in order to break it. So basically, most of the programs that I've seen is written in C or like C++. And the thing you can do with C and C++ is you can see like memory allocation pretty closely. And it's just easy to debug with like GDB and things that you use in mechanics, I guess. And you will need to use Python for exploit development. Like when you write the exploit, there's a library that I'm gonna talk about later, which is basically in Python that's gonna help you like a lot in writing the exploit. The last thing, but I think it's also really important, is assembly language. Like if you don't hate yourself, then I don't think you're gonna like it. But it's really crucial to exploit development because you typically given like a black box, so you will need to reverse engineer it in order to know how it works. Like it may be doing something else that it doesn't show up in the output. And so basically, you need to figure out what a black box does using assembly. And the typical architectures that I've seen in CTF is x86. There's a lot of stuff in this architectures, but I honestly haven't like really written a complete like x86 programs before, but I know how to read it. So I spent a lot of time and also like practice through CTF. Like I just read it and I just got accustomed to it. So yeah, so these are the programming languages that you're gonna need. And next up, the tools that gonna make you hate yourself less. So there's a few types of tools that you're gonna be used in exploit development. So the first one is disassemblers, which is basically it's gonna take like a compile binaries and it's gonna show you the assembly code, like human readable kind of code. So you can start figuring out what it does. So here's some of the common ones that I listed here. And the next class of tool is debuggers. The one that I use right now is basically like the enhanced version of GDB. It's called Pwnback. That's what it's called on the GitHub repo. I'm gonna show you what it can do later. But basically, it just makes like it helps you to see everything inside memory like way better than the original GDB. And the library that I mentioned before, written in Python, is PwnTools. So basically, it has like a bunch of classes and a bunch of functions that's going to help you interact with service, like remote services and binaries, and help you format the numbers inside memory. Like if you know little endianness and big endian, it's kind of messed up when you do it by hand. But with this library, for example, you can just like give it the number that you want to appear in the memory, and it can basically like do all the math for you to make it appear like exactly like that in the memory. So, and lastly, I think Linux is a pretty good place to get started in this Pwn thing because, man, it has something that doesn't have on Windows that's going to make you see the exploitation process like easier. So the next thing in the starter pack is, do you want to need to study how a program is mapped in the memory? So basically, you need to study like how a process works. So in the process, there's a few kind of memory segments So basically, you heard of it like stack and like the heap, and other segments as well that has codes in it. And you will need to learn how these memory segments are used when the process is running. So basically, for example, when you call a function in a C program, you may not know about it, but in like the low level, like CPU and like all the instructions, it's gonna happen on the stack. Like you're gonna push the address that you wanna return to after you call the function, so you know where you can return to. Like the return statement in the function is basically that. And also memory allocation uses the heap. Yeah. And the last thing, you will need, I think, in order to like get good at like anything, you will need to practice for a certain amount of time. So there's a lot of places that you can practice, and I think the best place to practice is to CTF. So basically, CTF happens like every weekend, and also there's another thing called War Games, which is basically like untimed CTF, where it's just like up there and you can go and you can solve challenges. So CTF is a good way to practice because I think the challenges of every CTF is new in some way, and it's not going to be like repeated. So you will kind of always learn something new out of each CTF in this way. And the last thing is you will need to spend time to practice on this. It depends on like how you progress, but we all need to start somewhere. Like I personally spend a lot of time doing this, so I don't have a life. So demo time. Just some of the demo of the tools that I talked to you guys before. This is too small. Okay. All right, so this is the challenge, the CTF challenge that I mentioned before. The first one that I got like in my life. It's so this is Linux, and so I'm gonna show you how I approach this challenge. So basically, when I'm given this binary, I don't know what it is, right? So the first thing I'm gonna do is I need to figure out what it is. So the file command is gonna show you like which type architectures this binary is, and is it dynamically linked or not, and like some information about it. And after I know something about it, there's the disassembler, which is basically gonna represent the binaries in assembly code that helps you learn like how it works underneath. So this is Binary Ninja. You can see it shows all the functions on the left, and I can just click on this one, and these are the assembly code that I just talked about, and these are assembly instructions, which is basically really tiny operation that you carry out, like not like in C code, where you can just call malloc OX 100 and you get a piece of memory back. So under the hood, this is like all that's happening. And so yeah, this is this assembly. So now I know something about it. I'm gonna try to run the binary to see what it does. So all right, so it's waiting for some of my input. It's asking for my name, and it has like some information out here. So I'm gonna try to give it some input like this. Okay. All right. So this is some of the input, and it just echo back the input. So if you've been doing this for long enough, what you typically do is you're gonna try to give it like a very long input. So for example, I'm gonna give it like a 10,000 A to see what it happens, because typically what it's gonna do is like overflow the buffer, the piece of memory that it's trying to store our input in. So yeah, so something happened. Yeah, just something weird happened. I don't know. So 10,000, 5,000. All right, so maybe it's not gonna crash, but you kind of get a point. It's kind of break. It's not as intended. So this is how an exploit is gonna look like when you solve a challenge. So pwn is basically the Python library, the pwnlib that I just talked about. And what I'm doing basically here is I try to interact with the process from within this Python program, and I try to get some information out of it. I try to build my payloads, like craft my payloads so that it's gonna behave the way I want it to do. Have a thing called shellcode, which basically like a piece of malicious code that's gonna give me a shell on the machine that's running the binary. And these are just me sending the payload to the program. So in action, it's gonna look like this. So I'm just running my code right now. And this is what it does underneath. So basically, I'm getting a shell now. So if you can imagine that just from that binary, I give it some input, and I get like shell on it. I can execute other command like just read files, or I can execute any command that I want on the system. So that's basically how a CTF challenge of this kind is going to look like. So another tool that's pretty cool is pwnback. I know it sounds weird, but it's called pwnback. So why it's better than the original GDP. So I just loaded the binary in here. You can run it as normal, like just give it some input. Looks pretty much like the original GDP. But the thing is, if you print out the function, so for example, I break out the main function, it's gonna like be like this, and you run it. This is gonna be the thing that's different from the original GDP. So it's gonna show you everything in one screen. It's gonna show you all the registered values. It's gonna be like the instructions that's closer to the program counter. It's gonna show you the memory on the stack. So you can see if you can make use of any information. And it's also gonna show you the backtrace. Another thing cool about pwnback is you can kind of see a bunch of consequence memory using the telescope command. So basically, I'm gonna do like, yeah, so basically you can use the telescope command to see through like a bunch of consecutive memory like this. And if there's memory allocation going on, you can use the heap command. It's not happening yet, so I'm just gonna keep executing the program. And at some point, if you wanna see what memory allocation happened, you can use the heap command to show like the metadata and the data of the memory chunks that's being allocated. And that's just a bunch of other commands that I feel really helpful using it. So feel free to try it out. So does anyone have any question at this point? No question? All right. So just another demo that I want to show you guys from what I've learned at the reversing interest group. So Stuart was the one who actually brought this to the group, which I think is pretty cool. So the one that I showed you before, basically it's called browser exploitation. It's not the thing where you can pop an alert box like using JavaScript. You're actually gonna get like remote code execution if you want like malicious JavaScript. So this is the computer that I'm running my Chrome browser on, and I have a website loader here. I'm gonna have a netcat listener listen for my reverse shell, and basically I'm running Chrome, and I'm gonna try to visit like a malicious website. So I have the page here called test.html. So I visit that site, and what I got back is a shell. So it's pretty creepy if you think about it. But if you want to learn more about this stuff, we have it at the Reverse Engineering Interest Group. So if you want to look more into that code, it's basically just an HTML page that includes some JavaScript. And this JavaScript is just like a bunch of stuff happening on. But under the hood, it's basically what it does is just doing the exact same thing as when you exploit the binaries. So in this case, it's exploiting the Chrome browser binary. So I think that's pretty much it for the demo. And I have some final thoughts about this. If you want to get started, to me, when I started it, it felt pretty tedious when you started this out because you would need to go through like each of the assembly instructions. So it sounds just really tedious in the first place, and I really wanted to give up at that point, but I know why. I just kept doing it. Maybe I just hit myself. So also there's a lot of things involved. Like I said before, just from the starter pack, there's a lot of stuff going on. So I just want to say, if you want to dive into this, just be patient and just be persistent. Just stick with it, and just spend more time, practice deliberately. I steal this concept from this talk from Ned Williamson at this 35C3 conference recently. So basically, I think practice is helpful when you actually like do something that you didn't think you can do before that. It's gonna like raise the bar after you practice. So yeah, and there's also a bunch of resources that you can pretty much find like from this list. And there's many of those that I cannot remember from the top of my head. And in the reversing interest group, we have like all this kind of stuff. So if you're interested, you should probably come. We have people of like different levels. Even if you know nothing about it, we're still willing to like guide you through all of this. And also, the team contagion is the CTF team here. We're trying to play some CTF. We're trying to play CTF more frequently. And if you want to practice, just come and joins us. So, yeah, I think that's it. Does anyone have questions? No question.
Thank you.
All right.
Next up, we have election rigging by Perry and Christian. Come on down. Do not be afraid. They will be discussing, well, hello. Hey. And there's also Dave Cook. Hey. Everyone. So, here they, oh, no. This is a microphone. One of you must hold the microphone.
Thank you, Nick.
Yes. There you go. I forgot my peace tea. I can now be at peace. Have fun.
I'll leave it here. I think I would just pass it to you. Election rigging. Do you really need it? This will help you decide. So first of all, why I'm talking about this? Well, election rigging is a big buzzword recently, especially with the Mueller report. I don't know how to pronounce his name, but the Russians have been found to be interfering in Americans' elections. And of course, there's the other stuff with Assange, and all of this is just really creeping up on everyone's minds, and everyone's thinking about it. And election rigging is just a hard skill that is really demanded in the labor industry, and it is the skill you need to find a co-op and a full-time job at some sort of a government agency. So, and for us to gain more insights into how election rigging really worked, I decided to carry out an experiment. Of course, this is totally legal. I wasn't rigging any actual country's election. So I picked RIT and its various sorts of student organizations who all hold some sort of elections. And since RITSEC literally just held the election last week, and it also has the name security in it, it must mean that it's the most secure election on campus. So I decided to target that one. If it was going to work with that one, it obviously was going to work with all the other student clubs. With that being said, disclaimer, RITSEC's electoral integrity was not in any way affected by this sad experiment. Any rumor that the e-board is elected through rigged vote is false. There's no evidence of any tampered votes or fraud. Please do not hurt me. So why are we qualified to talk about this? My name is Perry. I'm a second-year computer science and computing security student. I am the Chinese hacker, and which makes me a very good target for doing this kind of thing. Like, in the past, historically, it's been the Russians and the Americans who have been doing this kind of electoral rigging stuff. And if we want the election rigging industry that is sustainable and for the future, we need a diverse range of labor pool. And that's why, as a Chinese, I feel I was obliged to carry out this task.
And my name is Christian Brady. I'm a fourth-year CSEC student. With my experience, honestly, it's more of just being noticeable. Perry knows that I'm very observable about people, and frankly, it was just more of a test to see if students that he hired could come in as agents and see and possibly sneak into their way to become agents and possibly rig the vote. So he just came to me for a little bit of personal advice and to be a cohort in this whole thing. So it's more of just getting me as a sort of third party in terms of finding an agent who's very observable and just finding out what types of behaviors that these agents provided that would have either give them a little bit more of an advantage or disadvantage when entering these types of environments where they don't really belong.
So how it all started? It all started last Tuesday. So I was talking with a bunch of friends, and although I was very busy, I was trying to finish a concept of a computer system project. But after I finished it, somebody told me that there was the RITSEC election going on last Friday. And apparently it was members only, which got me thinking, because how do you tell if someone's a member, right? Like sometimes I don't come to the RITSEC meetings that much, and when I come, I usually don't sign in, unfortunately. Sorry, Nick. But you do present. I do present. But members only, right? What if I'm not a member? But I want to vote for my friends? How do I vote for my friends if I'm not a member? Would I have to commit electoral fraud? Well, it seemed a necessity at the time. So if I was going to commit some sort of rigging, why not make it big, right? If it's just myself rigging, it's not really doing the rigging. I gotta get a lot of people doing this. So I started thinking about how to go around with this. I asked around, and people told me that they were using Google Forms to collect the response. And apparently, it required all the voters to be physically present in the auditorium. They also told me of this RITSEC repo on the GitHub where they recorded the script they used to count their votes. So that was Tuesday night. So on Wednesday, I decided to actually plan this whole thing. So of course, being a computer science person, the first thing I did was to look at their code. So this was the code they used to count the vote as of last Wednesday. Obviously, they were using Google spreadsheets to count the votes from their Google Forms. and random, which we don't care about, graphing the votes, which we don't care about. And they were using this OAuth 2 client thing, which I didn't care about. But apparently they are using a rank choice, and they're doing a bunch of plotting stuff. And they also had different spreadsheets for different positions, which was interesting because it seems it was, from this I was able to infer that they had a different Google form for each position. And each Google form was probably exported to some sort of Google Sheet where they, which is the database they use to count their votes. All of this is just visualization, which is not important. This is the part. They are very beautiful. I was very impressed. I was very impressed by the work in putting
Very
this. Thank you.
aesthetically pleasing.
Yes, I actually did it on fake votes, and it looked wonderful. But this is the part where they actually count the votes. So they open the worksheet and they use the Google API, and it looks like the first column is the timestamp, and they emitted the timestamp. So whatever their spreadsheet was, the first column was timestamp. And number of candidates equals to the length of all the other columns. So it looked like if the first column is timestamp and all the other columns, the number of all the other columns equal to the number of candidates, then it must be that whatever else information, it's not the timestamp and it's not the candidate. So it was obvious at that point that there wasn't some sort of email information in the spreadsheet where they actually count the votes. And I did some testing on Google Forms, and it looks like when you export the Google Form responses, every column except the first column by default will be the answer to the question. So apparently for every position, every candidate is formed as some sort of a question, and there wasn't recording of any sort of emails. And I looked through the rest of the code, and it was all counting, and it was obvious that they weren't doing any sort of validation. As far as this code goes, they wasn't doing any validation. And the public information available at the time made it seem like it was a very vulnerable process where if you can just get on the form and cast some votes, then they will count it. So this was the Google code. And so if the Google form is vulnerable, how could I attack it then? I could get a bunch of bots, but that would be breaking Google's terms of use, and as a law-abiding citizen, I wasn't planning on breaking Google's terms of use. So I needed a bunch of physical people, actual people, who could show up and then show up to the auditorium in Magic Center and then vote. But then there was still a lot of incomplete information. I didn't know how the vote was actually going to go, other than that I was using some sort of broken Google form. So I needed insiders like Christian who could, update the agents on the most up-to-date process about how the voting goes to make sure that, all the computer scientists who show up actually know how to vote. And that's why I needed to recruit agents and recruit insiders. Surprisingly, so far I've made a lot of assumptions, right? I could get, computer scientists to show up and rig the votes, and I could get insiders who could update all of this. This was a lot of assumptions. And I also assumed that people would actually do this for me. And the only way to find out if those assumptions were valid was to actually do them. So I went around Golisano. I talked to my friends and asked them if they're interested in committing electoral fraud. And surprisingly, a lot of people are excited for this. Like I asked them if you're interested in wasting a lifetime opportunity to rig an election, people would say yes. People would say yes to my question. And I recruited 14 agents and 2 insiders on Wednesday. So on Thursday, I got most of the stuff I needed, but then I was, kind of looking for some sort of collusion, right? Like if it's just me intervening in this election, then it's not really exciting. Like I need to collude with the e-board members about what's going on, and that will make it a real rigging. So I reached out to the e-board members, who did not give me very kind responses. And basically, they told me to not mess with the forms, and if I did, I would get kicked out of the club. So I was like, oh shit, I guess I'm not really messing with the board. And if I did, I don't think they would find out, but at that time, I realized, this thing got serious. I couldn't just, do this without, some sort of a change in my plan. And a few hours later, after I talked to the e-board members, the report was actually updated by Nick. And as I was checking it, well, I'm not going to go through it right now. The updated repo included some sort of validation, cross-referencing the voting with a list of constitutional members. So it was obvious at Thursday night, the night before the election, that whatever rigging I was planning on doing wasn't actually going to work. And if I did, I would probably get kicked out of the club anyway. But I already got like 16 people signed up for this. How would I still wanted to find out, if a bunch of computer scientists can really do this task of, doing this whole very exciting thing. So I set up a fake form according to my analysis on the county. I set up a nearly identical form, which looked like this, which looked like that. So it was actually very close to what the actual form was. And I set up one for the presidential voting, where my agents would go in there and they talk to the insider, and the insider would give them the link to this mock form I set up, so they would actually not be affecting the real election. So Friday was the day of action. I was behind the scene. I was not actually on the scene most of the time, so that if they kicked him out, this scene would still work. And I got Chris as my insider number 1 and Muhammad as my insider number 2. And I got 15 people who signed up who said they were interested in doing this for me. So unfortunately, as it started, a lot of people were already out of the game already. Muhammad, although he was a fantastic individual, so to get this to work, I had to hand out mission briefs outside where the voting actually took place. And on the mission brief, I put in pictures of the insiders whom the agents would be meeting. And the picture of Muhammad was unfortunately so out of date that none of the agents was able to actually find him. So Muhammad was out of the game. And out of the 15 people that I recruited, only 7 were able to show up. All the agents went cold turkey. And their last name have been omitted to protect their privacy. So you won't able to know who they are. So these were the 7 people that showed up, that were able to show up. And out of the 7 people that were able to show up, only 4 of them were able to show up on time before the presidential vote ended. Remember, I only set up a mock vote for the presidential vote, so if they showed up later, I wouldn't have any fake forms for them to vote on, and they would have to vote on the real thing, which would got me kicked out of the club. So for the 3 of them that weren't able to show up on time, I told them that it was mission accomplished and they should go home. So 4 people were able to show up on time. And out of the 4 people that showed up on time, only 3 of them were able to find the auditorium, which is understandable. Like for most of us, it's our first time inside Magic Center, right? Like it took me a lot of time to actually find the auditorium myself. So it was understandable that one of the 4 people who showed up just could not find the auditorium at all. Like after this whole thing finished, he was still walking around trying to find it. So I told him that it was mission accomplished, And out of the 3 people that showed up, only one of them remembered to not bring pizza into the room. So 2 of them brought pizza into the room, and I think they got kicked out. But fortunately, it wasn't the end for them. They were able to finish their pizza and got back into the room. This could be wrong, so correct me later if I was wrong on that. And out of the 3 people that made it into the room, only 2 of them were able to find the insider, Chris, in time. Like the other guy, because the room was so dark, it was hard to find people. Like it was really hard. It took him a lot of time to try to act normal and then at the same time trying to find the insider on the picture that I showed them. So one of them was not able to find the insider before the presidential vote ended, so he was out. And 2 of them actually approached the insider, and the insider was able to, Chris was able to give them the link to vote on. So at this point, this was the end of the presidential vote, and it all looked pretty dandy. Right? 2 out of 15 people actually succeeded in doing their task, or as so seemed. So the next day, I checked, which was Saturday, I went onto the mock form I set up and actually validated that the 2 people who claimed to have finished the mission actually finished the mission. So it turns out that only one of the 2 people who claimed to have finished the mission actually did the mission, like actually followed the instruction. It turns out that this other guy, Eric, who said he voted on a fake form, actually voted on the real thing. So I was like, oh fuck, was I going to get kicked out? So I immediately contacted Nick to verify that Eric was not voting on the real thing. Fortunately, Nick told me that Eric, unlike what I thought, he was not who I thought he was. Okay, so he was actually a constitutional member of RITSEC. So he social engineered me all along. Like he was not committing, he was not committing fraud in any kind. So I was fucked, and and he was just doing his own thing. So, and that was the result. And the insider Chris, since I was most of the time I wasn't actually in the room, Chris will be talking about how it actually went in the room.
Okay, I didn't really have time to add slides to this. I would probably add a little bit more information about how it went down inside. Basically, the two of them, Eric and Alex, did manage to find me only because they walked through the right side of the doors. I was seated like one row front from the back row, and not on the ends, but relatively near the end. So I did have both of them sit relatively next to me, one sitting in the row in front of me, the other one sitting in the row behind me. I'm assuming Eric was the blonde one, right? Yes. Yep. So Eric was sitting behind me, and first I'm going to talk about Alex. Alex was the other one, right? Then, okay. So, not Eric, but the other guy. I wasn't Nathan. Okay, Nathan. He came in. Obviously, he didn't really look like. What drove me suspicious, first of all, was the fact that he came in and just did that really suspicious like look around, just making sure he wasn't like spotted or anything like that. He was very conspicuous, I would say. A lot of people here I've noticed tend to wear like jeans and t-shirt, or like if they're wearing a button down or something, they always wear like long pants. The occasional people who wear shorts always usually just wear like athletic shorts. He came in with a generic like Bostonian look of just like that black like sweatshirt jacket and the black cargo shorts. So that immediately just like made me really suspicious because no one really looks like that. He was a big guy too, so he wasn't really that conspicuous either. And he was just very nervous looking, looking at he was at the end of the row. So in terms of being an agent that would have been successful in a very visible room, fortunately we had the visibility down because it was a theater and we had all the lights dimmed. He managed to, I guess, slip under the radar. I definitely know that some people would have found him suspicious. But Eric was sitting behind us, and Eric, he did a pretty good job. Unfortunately, our passcode for getting my link was, hey, do you know Perry? And for anyone who's been here for a while, everyone knows Perry. Who would ask that question? So it didn't strike me as an odd occurrence until later that maybe we should have changed the passcode, because that's a very suspicious thing to say, especially like if you're saying it out loud in front of people. So with Eric was a little bit less suspicious. Unfortunately, half of like our most senior members were in the back row too, so that ended up being a little bit suspicious either way, because Eric was sitting next to a lot more senior members, even if he was already part of the club. So I'd say Eric he infiltrated well, and Nathan was kind of iffy. I wish I had a picture to show you guys, but I'd say he's about like 6 foot, very easy to notice. Very large builds, very thick. But yeah, just in general, if you want to, I guess, infiltrate more of these situations, I guess the first step would be to find out who your audience is, or who the group is you're trying to slip into. Because if people tend to have like a tendency to have sort of clothing or uniform or something, you really want to look like them. Otherwise, you look very, very like conspicuous, especially if you're a larger set. You'd look very suspicious if you see this very big guy that you've never seen before, like in this club, just walk in and just nervously just like look around, it's like with darting eyes everywhere. And thirdly, kind of use a passcode that has no personal attachment to the actual election or to the actual club itself, because Perry is a very noticeable person. He does talk to everybody. He's very sociable. So I think I would recommend just doing something that kind of relates to what we're doing at like here, like maybe like a class or something, or just have a passcode that kind of relates to the organization, but not necessarily in terms of ousting yourself as like a stranger.
Thank you, Chris. So that was the result, and I think out of the 20 names, 18 names that are here, one of them is actually here today. Eric, would you come show up? I would like to shake your hands or whatever. Eric is the guy that did not follow the instructions, the roach agent. Thank you for your service. And so what did we learn about this, right? We had 15 agents, one of them succeeded. Obviously, this was a very small sample size. If we were to use statistical analysis, such as applying the binomial distribution on this, we would need a success number of at least 10, a failure number of at least 10. But here we have a success number 1, so it was impossible to do any sort of statistical analysis on it. But if we just take it at face value, let's just say that my people were the best people, and 1 out of 15 success rate was the best you can get from Golisano. How many people you need to recruit in order to actually rig an election? So I'm not showing the math here because I didn't have time to do the slides, but if we were to do the math, right, 1 out of 15 success rate, and you have maybe 100, 200 people who voted. So let's say 100 people voted, and 60 of them voted for candidate A, and 40 of them voted for candidate B. You need to make out the 10 votes somehow through the rigging, right? And if you have 1 out of 15 success rate, you need 150 computer science. You need 150 computer science majors to actually carry out the rigging successfully. And if the number gets any wider, like if it's a landslide election, then it's just you need up to 1,000 computer science majors to actually rig this. So obviously, it wasn't very successful. Like you cannot just turn Golisano people into spies in a few hours. And I think it also attested to just how secure RITSEC really is. It really stands up to the name, right? RIT Security Cup, it's secure. There's no rigged votes. Nick updated the code in a spectacular short amount of time. So I'm very amazed by that. So this is what we learned. Any questions?
So after your code audit, did you responsibly disclose to eBoard, or did you just say what you were going to do?
I just said what I was going to do. I don't know what responsible means. So, what's the other question?
How do you think your outcomes would be different if you leveraged online social media platform Facebook in your operations?
It would be possible, but again, using some things like that, it would disclose the operation, right? Like if Russia has a lot of resources, so they can afford to, just be blatantly rigging an election. But I don't have that kind of resources. I cannot just go around posting on Facebook that, hey, I need to rig this election. It will put a really bad name on me. So it was obviously I had to do it in the dark corners of Golisano. Yes. Any other questions?
Yeah, why are you guys still not connected on LinkedIn?
Sorry, what?
You guys still aren't connected on LinkedIn. Why is that?
Are we connected on LinkedIn?
We connect.